Hello everyone and welcome. If you can hear me, if you can see me, please set the thumbs up in the YouTube chat so we will know we can start. That's Alex Voloshev, developer advocate at DataStax, and today with me Zig Dean. I hope you know him already from the last episode. Hey Zig, how are you doing?
Hi, how you doing, Alex?
Yeah, very well. I'm happy to be here today. Could you please greet our attendees and I will leverage the sound level for you?
Sure. Well, nice to meet everyone today. I'm Zeke Dean. I'm here at DataStax to talk about developing applications on Pulsar today.
Yep, perfect. Now it sounds much better, I believe. And uh, let's start then. So let me see at our YouTube. It looks like we have a lot of people today, and that makes me happy. And we will have much more people in few minutes because there are always latecomers, but you who joined us already, you are the best. So let's start. Let's not wait too long. I see some familiar names in the chat. I see some new names, which is also very great. I want to answer a question from Ivan Garcia. Is there any homework to be done on our own? All of them are done during the live sessions. So yes and no. We do the labs during the lab session, during the live sessions. Indeed, you can do them after that. So it's not necessary to complete them during the workshop, but you can do them after, like to have more time to think about that, to try to make experiments and so on. Or better, try both. And then later to get your participation certificate for this workshop series, as it consists of 3 episodes, you will need to submit the screenshots of your all the labs done. We are going to do overall, Zeke, fix me if I'm wrong, we are going to do overall 5 labs, correct?
Well, for right now, we have 3, but
Yeah.
yes, eventually there is a plan for 5 labs.
Yeah, so last episode we did 1. It's available online, so you can do it after all. It's no worries. Today we are going to do 2 more to next, and then for the last episode we will prepare some more for you. So we will see in the end. So we will be at least, I believe, 4 different labs. And to get your participation certificate, you have to watch all the streams live or recorded and submit a homework. I will explain it in the 3rd episode. I see a question, missed the first session, any place I can catch up? Yes, absolutely. So recording is available, and all the labs are available as well. I will send a link to the YouTube chat and we will proceed because we have to start already. We have a lot of things to do today. So that's the repository. Week 1 is updated and I will update week 2 today. And that's the main repository with all the materials for this series. But in general, Taib Ahmed, don't be worried. We will be very briefly, but we repeat the materials of the first episode. I think so. We will see. So now we proceed. Ladies and gentlemen, welcome to DataStax Monday Learning. It's a special program that engineers talk to engineers about the open source technologies, with the hands-on experience, live communication with the experts about the most important topics which every developer needs to know. Personally, for me, event streaming and the related technologies, messaging, notification, queues are essential, and I would never consider a developer to be a senior level developer if he or she doesn't know those. So let's go. What are we doing today? Today it's the episode 2, Pulsar in Action, for event streaming series, led by Zeke and me, and that's the second one, June the 14th. Hope you watch it live, but if you watch it recorded, no worries, you still can ask us questions in our Discord server. So, we will talk about a few things today. Why messaging, review Pulsar, messaging patterns, schema management, and SQL with Pulsar. It sounds a little bit weird because we used to use query language for relational databases. And now, what do you mean by SQL with Pulsar? Could you maybe clarify that a little bit, Zik?
Yeah, so imagine you're a data engineer or you're a business analyst, or you're an engineer and a business analyst comes to you and says, "Hi, I want to query Pulsar. How do I do it?" So the thinking behind Pulsar SQL is it gives you an ability to query for specific data within your Pulsar topic to solve a particular problem. So it's a very good and easy way to gather information from your cluster without having to write code, basically.
Yep, and that's quite cool because, well, ability to communicate and retrieve data like that. I would say it's, I mean, I don't know each and every messaging platform in the world, but for those I was working with, I haven't seen anything like that before.
Yes, it's based on PrestoDB, and we'll discuss it later. We'll have a hands-on lab as well.
Yep, perfect. And last point, before we proceed, if you have been to our workshops before, then you know the story. We use Menti for the two things. First, we ask questions to you with Menti, so we know what's your status. Are you in for this series since the beginning, or you are a newcomer, and so on and so forth. And in the end of this episode, we play a game, we ask you questions, and if you give the right answers and do it fast, you get the prizes from DataStax. So that's quite cool. And that's amazing, basically. Now I see, I know why the first answer, yes live or yes recorded, comes in first, because those who was at the last episode, at the first episode, they know what to do. And if you wasn't there, then answer is simple. Please go to menti.com and use the code 26484290, or just scan that QR code next to Zik. I will move myself a little bit so you will see the code. Boom. That's good. And you will just put your answers there. So if you want to have chance to win the prizes during the competition, during the quiz, you better run menti.com. Easiest way to do it is just open it on your mobile phone, go to menti.com and put the code or scan the QR code as said already. So, well. Menti.com, code 26484290. And let me see how many people answer it already. Oh, finally, we have some newcomers. It means what you managed to deal with Menti and jump in. And that's great. You are doing well. So, most of you watched the content live or recorded, and we have some newcomers today as well. Okay, good. So, we can move on. Have you completed the first episode lab? I will remind you, it's in Katacoda and it's very basic one. We're working with Pulsar in command line interface using Pulsar admin, Pulsar client, and so on. So that's actually quite a lot, I would say. I've expected what the proportion will be completely different. Take a look, Zik. We have like almost 50-50.
Ah, I thought so.
Now we have finally clear 50-50. Well done. I thought it will be much worse. So that means you are doing really well. Today we will do it again. I hope you like Katacoda as much as I do, because it helps you to do the exercises without installing any software on your laptop. You know what? We are running workshops weekly on the different topics, and if we would make you to install all the software for all the workshops we are doing at your laptop will be exploded very soon. That brings me to the next question. Have you been to any of our workshops before? I believe we have some fans who attend all of them, and I think some of you visited at least once or twice. We have some newcomers, which is great. Congrats. That is nice. And those who do it regularly, those who are our fan, that's you are the best. Like, and thank you so much for joining again and again. That is cool. So, welcome newcomers. And finally, which queuing or messaging technologies are you familiar with? You can pick multiple options. Hi, Ritvik. Happy to see you here. Okay, there's a lag in Alex audio video. Okay, as long as audio is on time, video doesn't matter too much, but I will check what's going on with the synchronization. So, okay, so looks like Kafka is a clear winner, and that's pretty understandable. Now, for today, I do expect to have more answers for Apache Pulsar for real. Most of you attended the previous episode. It means what you are kind of familiar already. So please raise the number on Apache Pulsar. That definitely makes sense. And doesn't matter if you have experience with things like ZeroMQ or RabbitMQ, that works well for us. And if you have no experience with queuing or messaging technologies, you are very welcome as well, although it's episode 2 already, of course, so it's maybe too much. So, we are done with the leading questions, and we are going to switch to the slides and then to the lab. But don't close Menti, because we will run the quiz using the same code. And you may better keep it open till the end of the workshop. So, perfect. Let's go. We are going to cover some topics, and I want to be sure what everything is going well for you. And first one will be very briefly why messaging and what is it and how it works. Now, if you didn't attend the first episode, it will be a rough ride for you, but you can grasp at least the basic concepts. So, here we go. Why messaging, what messaging, how it works. In any case of the situation when your application works with different application, not only with the customer, before, like making an API call to Google or YouTube, for example, you normally do something like REST request or RPC request or whatever request you do, but normally with HTTP. And that means what? It's a synchronous blocking call. As long as service B won't respond or timeout will not be reached, application A doing the request in this case is blocked, and we'll just wait for service B to react. And hopefully service B will react, but actually network may be down, or maybe service B is down, or anything else bad happens, and so on and so forth. So there can be really a lot of different painful situations. What was the main problems of standard blocking synchronous calls? Doesn't matter if it's REST, RPC, gRPC, or whatever you prefer. First, huge risk with networking. As soon as the network is unstable, even if service B has completed the thing, application A may not get the answer. It needs or may need definitely service discovery. So application A needs to know how exactly to reach service B. And as long as you have only application A is service B, it doesn't seem too hard. But for example, one of the last projects I was working with included approximately 3 or 4 different dozens of different services, B, C, D, F, and so on and so forth. And communication and service discovery wasn't a simple thing. There's always a point-to-point communication. So application A needs to know which particular servers it needs to reach. You will ask me, like, what's the difference between point 2, service discovery, or service location at least, and point-to-point communication? I will tell you, the point is, in the second point we speak about, it needs to know how to reach. And in point-to-point communication, I mean, it knows which particular service to reach. You know, it's like with a message. Have you ever sent a mail like by post? Well, for email, it's usually the same. But sending the mail, like the paper mail, it really makes sense. You can have on that only one sender and only one receiver. And can you imagine sending a post mail? Then you have to stay at the post and wait till the answer. You know what? Even in the countries where mail post is very efficient, like Germany, I'm located in, it would take days. And in some countries where mail is not working so well, it may take weeks or maybe even months. Do you really want to stay in the post for all this time? I don't think so. So that's exactly the story. That's why synchronous calls are bad. From our human point of view, they are very quick. But in the computer time, it takes ages before you get the response, and application A or sender will be blocked all this time. So, slow blocking as you are waiting for your service to respond, or maybe not yours, maybe third party, idea is the same. Okay, so what's that situation? If receiver is not available, if no instances of service B is running, process is failed. And you know what? Sometimes it makes sense, because if you don't get answer from service B right now, you have nothing to return to your client, process is failed indeed. But in some cases, your message, your event, your notification processing can be safely delayed. Your client doesn't wait for your answer right now. For example, yesterday I made an ordered some spare parts for my motorbike on Amazon. I made an order and I quit the browser and went to do my own things. At some point, then everything will be fine with the order. They will send me a mail like, okay, we are dispatching your order. But I don't need this mail right now. The idea what, okay, we dispatching your order right now doesn't make any sense to me, because I will anyway get this order after some days. And this situation happens very often. So we need to understand what the background processing is. I will say again about that in a couple of slides. Is a very often the use case. Traditional flow in the web applications, specifically web applications, makes the most of the applications in the world now. Then is like client is requesting something, we will do all the steps to do to reach the goal, and then it's done. We will give the answer to the client, and client was waiting for it. As long as internet was slow and there were not so much to do for your application, it was okay, because client waits for some seconds for the answers anyway. But it was over for years already. People don't want to wait. If your application works 200 milliseconds slower than your competitor, people will switch to your competitor's application. So time is money, and we all know that. And what does that mean? Now the workload has changed significantly, and we are trying to dispatch answer to a client as soon as possible, and meanwhile do as much of the required job as possible in the background. Again, link to the next slide. And finally, next point on this slide, and last one and only one receiver. So when you are executing an HTTP call, you're going to always specify who is the particular receiver, which brings us again to point-to-point communications. You need to know what is that receiver, and you cannot send the message to multiple receivers. If you want, you have to do it at the application layer, watch them in parallel, and process all the response, and so on and so forth. Okay, so that's how it was before, and it is still the same for most of the applications. All small to medium businesses were more or less fine with synchronous API calls, REST calls, and so on and so forth. For bigger companies or for more complex projects, it's not the answer already. Messaging systems and answer systems work in another way. So they are a mediator in between of your application and all and every services you are going to reach. And it decouples message senders from receivers, and it's actually quite a huge benefit. At first, you may say, like, well, before application A was communicating with service B directly. And your messaging service, glorious one, doesn't make this communication faster. It doesn't affect my network. Before, I needed one network call and one network response. And basically, from the transport point of view, it was two packages of information. First direction, second direction, direction back. And now I have this messaging service in between. And that basically means what I need at least 4, or maybe if I have multiple receivers, as you say, maybe even more. Does that really help? Does it really worth the price I'm going to pay? Because in general, this scheme will work slower. And yes, that's correct. Under the same circumstances, you need to make more network calls. And in theory, it looks slower. But the price really worth the things what we get. What do we get? Now, application A is free as soon as messaging platform gets your message, because it doesn't wait for service B to answer, and messaging service confirms the message received nearly immediately. They are very fast. Well then, what's next? We can have multiple receivers, and it's on the messaging service point of view to process this thing. If you need to deliver message to multiple receivers, which is a quite often used case for event-driven architectures, it's done easily with messaging service, and you don't have to care about that in application A. Basically, you don't have to touch application A code when you add some more receivers, consumers, processors. And that's cool. So because they are decoupled, it's easier to extend your system. It's a perfect fit for distributed systems and or microservices. And one thing I really like, so message will be consumed by the next available service instance. It means what I can make some updates on service B, and my message won't be lost. My message will be delivered as soon as service B recovers and requests, okay, I was missing, what are the things for me from anyone? Sorry, I'm service B, I'm now ready for duty. And that's really a lot, and basically I believe literally all of the projects all of the projects you use are using one or another messaging platform. You use iPhone, 100% your message went through some messaging systems. You using Android phone, it doesn't matter, still the same. Basically, you use any phone, even in case you use like an older one, let's say, it still mostly probably will be processed by your telecom company, telecom provider with some messaging services, and so on and so forth. So you are using messaging services all the time. They are used by all the big companies and big and medium-sized companies, literally everywhere. Idea is different to the normal messaging. With normal messaging, you have one service dispatching, initiating the message, and one receiver which gets it. With messaging, usually it goes different way. First, the one who is interested in some message, in some information, in some data. So basically the receiver, one of them or multiple of them, have to subscribe for the messages you get. And most of the cases, it's also of course possible to unsubscribe. Then if anything interesting happens, service consumers subscribe for the message. And then service provider dispatches the message. It will be, service provider dispatches event E. In this case, event manager dispatches this message to each and every consumer who was interested in that. Well, not each and every, but let's take a look at that on the next slide. So there are two main types of messages you have to consider: queue messages and notifications, let's say. So what about queues? They are very different to notifications, to events. An idea of the queue is what every message in this queue will be processed one and only one time, therefore by one and only one consumer. And they may have multiple producers. So if you have microservice oriented architecture and you have a dozen of services, and some of them may need to send a notification to a customer depending on its settings. So the origin of the notification to a customer, can it be a short text message, or can it be an email, or maybe can it be a push notification via his phone? The origin can be different. Every of your microservices may need to dispatch this notification. And here you have some choices. First choice will be just, okay, that doesn't look too hard. I will implement a notification for my customer in each and every service because now I want to send them only emails, and then I will simply send an email to a customer from each and every service I have. And at first it may look like a bad idea, like a good idea, but in general it maybe ain't so great because you need to understand the story. And what's the story? Today you dispatch only emails. Tomorrow you send short text messages, SMS. Today and day after tomorrow you need like push messages, and maybe something else comes in. Maybe tomorrow you will use, I don't know, post pigeons to dispatch your messages. Well, not really, but definitely something new can happen. And then basically you need to extend every of your service to understand when to notify customer, how to notify customer, what's the current customer settings. Maybe customers say, write me no emails anymore, write me nothing, do not notify me about anything, I don't want to hear a word from you. Well, maybe he was disappointed at something you did before, shit happens. And then it means what now every service, instead of doing his own job, need to understand what's going on with your customer notifications. That's maybe wrong. What do you think? So in my personal experience, we prefer it on a huge e-commerce platform I was working on some years ago. We decided to do it in a different way, better way, I believe. All the microservices don't have to care about how to reach customer, and do we have to reach customer at all. If something happens what maybe customer has to be notified, they dispatch a message for the customer with, as you see, multiple producers, one consumer, and this message goes to a queue. Why a queue? Don't forget, every queue message is processed only once. You don't want to send to your customer hundreds of exactly the same messages. He won't be happy. And then each of those consumers, that's basically the same consumer, but multiple instances of that. If today we dispatch thousands of messages per second, we may need multiple instances of the same processor. But if tomorrow we have a low count, we may decrease amount of instances, we can scale down infrastructure and save some money. It's really easy when you round on the cloud, but you still need to understand what you are doing with the cloud. Otherwise, it will be easier to spend more money on your infrastructure than you would do with old school on-demand approach. Okay, so then we send all of those messages to a single service, which is a messaging service. It may have multiple instances, so those consumers are the same, just two different instances. That's very important to understand. And each message from the queue will be processed accordingly to the rules set configured for messaging to this particular consumer. And then we will send only email, only push notification, or all of them, or none of them if customer is unsubscribed for this particular message. Now, I really want to get this idea for you. Those consumer 1 and consumer 2, they are exactly the same, just different instances. It's like the same consumer, I launch it 2 times. They are doing the same job. And that what brings me to those points. With queues, we have multiple producers, single consumer, but we can have thousands of those consumers in parallel. Consumers share work. And that's again important to understand, especially in comparison with the notifications from the next slide. Consumers share work. They are like a team, which every one of them is doing the same job. And first one who gets the message will process it and send it somewhere. And what makes the 2 main features you start to think of queues? First, perfect fit for a background processing. When you have to do some work for your customer and you want to do it in the background, not making your customer wait, you send the message to the messaging system immediately confirms, okay, I got your message, next available consumer will process it. And then it's very quick. So the point is, overall system of multiple network messages is of course slower, but funny enough, your customer gets answer faster, and that's quite cool. So anything for background processing. What exactly do I mean for background processing? For example, application with profile pictures, and your customers creating their accounts, uploading their profile pictures, and they sometimes upload huge photos, like many megabytes, 20 megabytes, 40 megabytes, or maybe high-res raw quality professional pictures. Those may be like really a lot. Those may be really heavy. And you have 2 options. First option, make it uncomfortable for your customer and say we don't allow upload anything of more than 1 or 2 megabytes. Will that work? Yes, that will. If you are a government structure which has no competition to others, that may be the option you would take. But if you are a commercial company which wants to earn money, you have to respect your customers. And that means you don't want to depend on your background, on your servers processing those pictures and make your customer wait. Customer uploaded the picture, okay, we say, okay, we got you. You can go on and take your time, do whatever you want, use our service already. And in background, this huge image he uploaded will be processed by the first available consumer, which will make a thumbnail of it. And if you never used this asynchronous background processing before, I really ask you to have an extra homework, working on your project, working on your real project, thinking on your future projects. Think about this part of the processing must be synchronous. It makes no sense to deliver any answer to client before this one is not done. But maybe this part is backgroundable. Maybe I can make this part of my code to move this part of my code into background processing of the requests. It really makes your customers happy, then they get answers faster. Especially now it's easier with front-end applications. So, and second feature of the queues we need to think a lot is easy to scale, easy to distribute. As the consumers are all the same, and basically they consume messages one by one. Usually it's configurable, but usually we take messages one by one. You may scale them and launch new instances depending on the amount of the queue, depending on the amount of messages in the queue. So it's really easy to scale within the single data center over multiple zones, over multiple regions, and that's one of the most powerful things. So think of that as of the background processing first and of easy to scale mechanism which helps you to dispatch billions of messages per second with ease. So then we talk about queues. Our first thing is use case are basically workers. When you are making a move, you want your table to be moved to the car, to the truck only once. and there is no need to keep it, move it to a track multiple times, correct? So that's for the job what has to be done only once. And then we come to the next and last point you need to learn is a notification. They are very different so it's still the message as well, but it's very different to the queue message. What is a notification? With multiple producers, you also can have multiple consumers. And in this case, consumers may be very, 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 very different. What does that mean? When producer dispatch an event, what something happened, I want multiple parts of my system to react on that. So take a look. Many years ago, we were working on a distributed management system for a hosting provider, a company what runs web applications for you, company you can host your website on, and so on and so forth. And when you have a lot of customers and a lot of different offers, that's quite a lot of things to do. And typical situation was then the client requires, for example, creation deployment of a WordPress. You know WordPress, I guess. So we have an offer, client pushes the button, he gets WordPress deployed and ready for work. And actually, the trick is if you can do it against all simultaneously, step by step, very slow, and execute all the steps from the main centralized management system, which will get this query from a customer, will go put the files, when we'll go to create a database for them, when we'll go set up a proxy server in front of them, and then launch the setup process and then give the results to a customer. Do you feel like how I'm talking about that and it gets slower and slower and slower and slower? Yes, it is. So even a pure deployment of WordPress takes some time and we want it to be quicker. So how do we do it in a decentralized way with notifications? Idea is very simple. Service what works with customers dispatches an event, so request for WordPress. And that's a one message, or better to say one notification, which goes to a single topic. But there are multiple subscriptions on this topic from multiple servers. Server which responsible for files, service which responsible for files, we will call it consumer 1, will put files for the WordPress installation on disk. Then exactly at the same time, exactly in the same moment, exactly the same message, but different subscription and different consumer. Different consumer will change this configuration, shall change the settings on the proxy in front of all the installations. And the last service, which takes care of the database, will initialize proper database operations for this deployment, all of them at the same time by one single message. And you know what? Producer 1 has no idea of this group of consumers. So don't forget, in this case, those consumers are the same for the queues. They share the work. And with the notifications, those consumers are the different. They don't share the work, they do the different logic. And that's from logic, business logic, and also when you need to do different things. If we would need to do more things, like if person wants to deploy an application, he immediately has to pay for, when we just attach 4 consumer on the same subscription, on the same event, and it will react on this event. So the main things of the notifications are multiple producers, but multiple different consumers possible. You may have one, it's allowed, it's not illegal. It's a perfect fit for decentralized processing, and it's really easy to extend. Typical use case for those are microservices, or basically any distributed applications, including service-oriented. Well, it's more about microservices mostly. So that's it. Hi, Zeke.
How you doing, Alex? Well, thank you for that fantastic real world examples of,
Yeah,
messaging in the real world. I mean, it's one thing to talk about features, but it's very important to talk about the software development life cycle. And it's true, you can't solve most problems by just making a RESTful API call. It might work sometimes, but not all the time.
yeah, not for every project.
So based on our last surveys, it looks like about half of the audience has done the last workshop and the other
Mm-hmm.
half has not. So I'm thinking we can review the first lab and then we'll get straight into messaging paradigms. How does that sound to you?
Yeah, that sounds good to me. So I think I will switch to your screen, correct?
Well, very quickly, we can just share slide 22 and we'll just do the first lab directly. I think that's
20 slide 22. Give me a second. This
mm-hmm.
one. Okay. So yeah, that's right. So you know what? Don't be lazy. We deployed already. Or no. Yes. Yes, we should have deployed that architecture, the infrastructure for you to do the work. So you basically go to datastacks.io slash event streaming series ESS dash episode 2 EP2 dash lab. And now we do only this one, getting started with Apache Pulsar. So, and let's make it quick because we have more work to do and some of you did that already. Okay?
So we have about 5 minutes for everybody to refresh the lab. And that should keep all the people who've done it engaged from before.
Yep. So let me check how it goes. gtsx.io slash test slash ep2 dash lab. I will. Yeah, so it's available, so you can proceed. I will throw the link in the chat.
Install and run.
So, question from Smitha Gopalan. What's the difference between messaging systems and notification systems? So take a look. First of all, that's quite surprisingly good question.
Yeah.
I mean, because obvious answer would be there is no difference because usually the same system can support both queues and notifications and some other options. But it's not exactly this way because it depends on the particular solution you are using. So, for example, if we think of Amazon Web Services, if you know AWS, they provide two different systems for notifications, simple notification service, and for queues, simple queuing service, simple queue service. But for example, Apache Pulsar we work today with provides you both options. So answer is it really depends on one particular system you are going to use. Normally, usually, every messaging system supports both types of communication. Fix me if I'm wrong, Zeke. We have a little bit different background on that.
No, I mean, I think your answer is pretty good. Notification and messaging systems are essentially the same. There's always a listener on a notification system and a producer. So conceptually, they are the same thing.
Yep. Perfect. So, when you are done with your exercise, please set the thumbs up in the YouTube chat. We will know you are done. Yes, and Ashish Kumar also makes a good addition to the things I was talking about right now. The difference between push mechanism and pull mechanism. And actually, that's a really great addition I should have added to my slides. So Ashish Kumar, thanks a lot from my side. I will add it to the slides. Indeed. That's not it's not exactly the same for every system. But talking about AWS, SNS, SQS, that makes difference indeed. I want to make a push with notification service, so notification service will go and notify the receiver. And with simple query service in AWS, service will wait for consumer to come and retrieve the data. So mechanism comes from the consumer in this case. But normally I would say anyway, in other systems, our initial connection is initiated by the consumer. Doesn't matter if we speak about notification or consumer. That doesn't matter if we speak about queue or the notification.
Yeah, so the big difference between a push-based and pull-based system is a application that is using a pull-based system has to continually pull the service for new messages. So the perfect example of this is actually Apache Kafka. If you write a Kafka consumer, you actually have to request new messages from Kafka every X number of milliseconds. So that's kind of its feature design. It works exactly like a shark. You know, if the consumer stops pulling messages or stops swimming, the application will die and fall off the cluster. If you look at something like RabbitMQ or other more traditional-based messaging systems, basically it's the broker itself that sends the message to the client application. So that's a traditional messaging system and architecture.
Right. So I want to see how it goes, and I see many people are doing work already.
Nice.
So you are best. That's amazing.
Is anyone done yet?
I see 5 install and run completed.
Okay, that's good.
And Java client 7 started, 1 completed.
No one do the Java stuff yet. You're cheating. You're cheating, whoever you are.
Yeah, please don't run in front of a train. We will reach this point with the Java parts. So if you did the homework, if you did the first part already, then go get your tea or cafe or whatever you prefer. But don't proceed with the Java client. We will do it soon, but not right now. But yeah, that's cool to see what people are doing that, and people are reaching that as well.
Should we give people more time to complete the lab, or should we just jump straight into
I see so far only 1 thumbs up, and I see so far in Katakoda dashboard what we have only, let me check, 8 completed install and run scenarios. So let's give a couple of more minutes. We will try to answer questions sometime. For example, Ritvik, if you did getting started with Apache Pulsar already, no, you don't have to run it again. You just can, I don't know, grab some tea or whatever. We will proceed.
Give us 3 minutes and we'll get started with the rest of. Yeah, this is for the 20 or so people that didn't attend the first workshop.
Yep. And then Ziauddin claims Kafka and Pulsar are dump pipelines. Well, I can accept pipelines part, but about the dump part, if you would take a look at the architecture diagram of Pulsar, for example, I wouldn't use the word dump in this case. Hi Saverio. Great, scenario completed. Okay, more and more people are done. I wanted to answer one more question. So Ziauddin says in web application, WebSocket serves for push notification to UI. Yes, from the push point of view, push-pull point of view, that's the idea, which is similar to simple notification service of Amazon Web Services. But normally, for the applications working with messaging platforms, we use the approach, then the consumer goes to the messaging service and says like, okay, I'm ready, is there anything for me? And that's indeed maybe a bit better approach, because that's exactly what helps me to avoid the issue I explained it in the beginning. Then your push service tries to push something when simple notification service of Amazon tries to push something to a receiver. If receiver is not ready, it will retry a couple of times and well drop. So okay, there is a retry mechanism at least, but that may be not the idea, not the best case. And so normally messaging platforms work like, then you are available, you go and tell them, okay, get me what you have. And keeping this connection. So scenario completed successfully, completed. I'm happy to see you are doing the things. And I see 34 people started, 15 completed, what makes now almost half of the work done.
Okay.
Which is great. And you know what? Nearly no one has started a Java client after your words.
Good.
Yep, good. So, do you need some few more minutes to proceed? You can complete the lab after the workshop. And by the way, let me give you a link. The point is now for this particular scenario, we run a special training infrastructure. We pay money to O'Reilly Publishers House because it owns Katakoda now for you to be able to execute the steps, which is great. And now we go for, as soon as the workshop is over, after 15 minutes, infrastructure will also be terminated. And the question is, how can you do the exercises after the workshop? Answer is this link. So when you will want to do the things after the workshop, send it to your coworker, send it to your friend. You should use this link, not the current training link, because this one is dedicated for this particular workshop running right now. There is a question from Smitha. The first few slides spoke about messaging services, queues, and then notifications. I'm confused as to where this evolved in this order, or are we just going over concepts here? So that's evolving exactly to the practice. Now you know the theory, and we can proceed with the practice, applying everything what we discussed in the first part. So keep going, you will see the answer. And one more comes up from Tamarai Kanan. Hey, welcome to the club. And I think we have to proceed. 35 started, 18 completed. So over the half.
All right, that sounds like I think we're ready to move on. All right, everybody, now let's talk about all the different ways you can process messaging and all the different capabilities that Pulsar has to offer, and then we'll do a hands-on exercise in Java, and we'll also be writing a Pulsar SQL application.
Yep. Zig, but wait a second. I should switch to your screen, I guess.
Ah, yeah.
Yep, just a second. Okay. Yep, you are good.
Thank you. So if we recall, with all the messaging systems, there is always a concept of a topic. A topic is where messages are sent to and where consumers read the data from. So on a topic, you have producers which send the data, consumers which read the data and then acknowledge their reading position via a subscription cursor, or if you're from the Kafka world, that's called an offset. Then finally, there's another feature called a reader. A reader is basically a way to audit a topic without actually acknowledging a reading position. Now, there's two ways you can create a topic. One is a partition topic. So if you want to work in a Kafka type workflow, you have partitions. The other is a non-partition topic. So if you just want to send data to a topic and do traditional messaging, that feature is readily available. And topics, of course, have, security and multi-tenancy. We'll cover that in far more detail in our next workshop. So this is a diagram of how a message is actually stored in a cluster. So basically, a topic is a logical channel, right? But a topic is not a physical thing. It's like an address on a website. So when you go to an address on a website, you're not going to a particular location on a server. It's a logical place to put information or retrieve information. So a topic is exactly the same thing. It could be /users/news. That's exactly what it is. So topics are actually stored as partitions and segments and entries on Apache Bookkeeper, as you already know. So each message has an ID, and this ID consists of a ledger ID, an entry ID, a batch index, and a partition ID. So as you can see, a topic here has 2 partitions. It has 4 segments and multiple entries. And in this particular case, you have the batch index of the message because it was produced, the ledger ID, so which ledger it was written to, then finally the partition ID. So Pulsar is pretty interesting in that it allows both traditional messaging and streaming-based messaging. So we basically allow you to keep all messages and also to delete all messages after they are read. So you have that functionality. So the 2 rules to keep in mind when it comes to, messaging of Kafka, and there's 2 rules. One, Pulsar will keep all messages until they are read by a consumer that then acknowledges the messages. So if there's no messages that are outstanding, like unacknowledged, then it won't be deleted, and that's the default behavior. So if you just queue up a bunch of messages, Pulsar will store them indefinitely. So that's rule number 1, and you can change it later. Rule number 2, Pulsar does not intend to keep acknowledged messages in a topic with no subscription. So messages will only be retained until they are acknowledged. And once they are acknowledged by a consumer, they'll be marked for deletion, meaning they have a time, they have tombstones on them. So the difference between, let's say, Pulsar and a much older school MQ system is in those systems, those messages are deleted pretty much right off the disk. They do random disk access, they do a lot of searching operations, and it's deleted off the hard disk. So in Pulsar, deleting of messages is a background, operation that's part of the garbage collection and the tombstoning mechanism. It's very much exactly the same as Cassandra, and Kafka, in fact, works exactly the same way. But circling back to the actual slides here, as you can see, you have a producer, which sends unacknowledged messages, right? And then you have a subscription, which is the subscription cursor or the consumer, which has read, 2 acknowledged messages. And every time a consumer reads a message, the subscription cursor gets advanced so it can read the next unacknowledged messages. And once the message is acknowledged, it will then be deleted. Now, there is something called a backlog. So basically, a backlog is all unacknowledged messages on an existing subscription, and the slowest subscription determines the size of the backlog. And the TTL, or time to live, is the age or life of messages within a particular topic. And basically, this allows you to store messages to handle things like backlog growth. So it's very possible to oversize your backlog. So pretty much, in this case, you have a producer, which is producing too many messages, and you have a backlog of unacknowledged messages, and a consumer is reading them as often as it can. Now, every message has what's called a time to live. Now, this is an optional configuration, and what it does is it allows you to configure the age of unacknowledged messages. So if you're coming from a Kafka world, default messages are saved only 7 days, regardless of, the consumer groups. So you have that feasible functionality in Pulsar as well. Then finally, you have something called a retention policy. So a retention policy, again, this is to, if you're coming from a streaming or Kafka-esque world, basically a retention policy allows you to keep messages that are already acknowledged. So if you don't want to delete the messages and you want to just read them for later, maybe you need to replay data, maybe you have to save 2 weeks of data, that's what a retention policy is. So this allows you to run, for example, existing Kafka applications on a Pulsar cluster, which if you haven't had the chance, we gave a workshop, a webinar on that, I believe last week or the week before. But anyway, you should check it out. It's on our website. There's also sample code for that exercise.
I
The
think,
basic,
Zeke, sorry for interrupting. I think
yep,
we can put all the additional materials into the GitHub repo we created for this series. So
fantastic.
everyone who is interested to get more will be able to get more.
Cool. So I'll upload the code to GitHub as well for that. Should be good. So putting all these concepts together, basically you have a producer which sends a message to a topic, and the messages are at first unacknowledged, right? They go straight to the topic and they're stored on the Apache Bookkeeper. And these messages are queued up. Now, assuming that they're within the retention policy, then those messages won't be deleted, or even in the TTL policy, they won't be deleted, but those two settings play different roles. Now, once the message is read by the consumer, then the subscription cursor will move and, acknowledge the messages. Now, if there's a retention policy, the messages, will be deleted after a certain amount of time. And if the messages are within that retention policy, then they won't be deleted. So, does anyone have any questions on message size, TTL,
Let me
backlog?
check, please. So, pum, 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 pum. Can we create a retention policy for our convenience to create message application? Question by Vemalka S.
Yes. So you do have the ability, like you do in Kafka, to create topics directly from a producer. It's not recommended, but you can do that. There's administrative APIs. Generally speaking, you should just do it separately. Write an admin command, write an admin program, do it from a UI. But yes, your producer will create a new topic by default, and you can configure that topic in the producer side. So it's possible, but I would not recommend it. It's just not best practice, if that makes sense.
Yeah, I think so. Maybe we will get an extension for this question later. And let me check one. Okay, from Bala Narasimha Rao Anne. Zeke, can you elaborate more about namespace and tenant in terms of Kafka language?
Yeah. So the way to look at namespaces and tenants, Kafka doesn't have anything like it, but essentially what namespaces and tenants do is that they allow you to basically create a group of topics that can span multiple geographies, as in multiple clusters, and also, those tenants and namespaces have security policies applied to them. So let's say, for example, you're a forensic accounting team and you need to have your own special topic that spans worldwide and no one else in the company can see that data. You would create a special tenant called forensic accounting, and you'd create topics like auditing and, financial security stuff topic. And yeah, that topic would be exclusive to that team and it would span multiple regions. Another example would be a tenant called China only data. So imagine you're a global company and you need to do business in China, very common. And China, basically, they require you as an organization to lock your data in China. So it can't enter the country, it can't leave the country, it just has to be there. So in that regard, you could technically create like an isolated data set or even GDPR, right? Same thing, you can create, a topic or a namespace. Well, really, a namespace that would span or just run in a particular Apache Bookkeeper client along with a particular topic. I hope I answered your question.
Yeah, I think so. And let me check the rest of that. So, how many brokers exist per topic?
That's up to you. You could have, okay, so I need to go back way far. So basically, topics are stored on a broker, right? and a broker is responsible for messaging of the data. Now, bookkeeper is responsible for storing of that data, and those topics are stored as fragments on Apache Bookkeeper. And generally speaking, you should have 3, but yeah, you need to have at least 3 for leadership election. But yeah, the answer is at least 3. Technically, you could have 1, but it's a clustering technology. Don't have 1 of anything. Just reliability engineering 101, right? Okay. So let's talk about storage. So Ledger is a message storage operation unit. So basically, deletion of data happens on each ledger, and a message is not deleted individually. So the way ledgers work, and we can do a separate workshop on just operating a Pulsar.
Hey, Zeke, wait a second. We can't hear you. Okay, sorry, looks like we have a little interruption. Hey. Okay, we lost Zeke. Give me a moment to recover connection.
Can you hear me?
Yeah, now we can. I was writing in
I
Slack. Okay. So
I
you are
didn't.
good, we are live.
Okay, I don't know what happened, but we're good. So basically, with Pulsar, you store your messages on ledgers, and the storage size is limited by your backlog size and your attention policy. And your disk size should really be always greater than your storage size. So the other thing to talk about is tiered storage. So Pulsar has the opportunity to store data in cheaper storage mechanisms. So maybe you have S3 buckets, Azure blobs, or another hard disk sitting on your network somewhere, or Hadoop nodes. So tiered storage is how you can use Pulsar to be a cheaper messaging solution than, let's say, any other technology, because you can use very cheap storage. It's transparent to the client, and the same rules apply, right? You have message retention and backlog policy. So what this means is anytime you're using, tiered storage with a particular topic, that particular topic will have the same backlog, retention, and acknowledgement settings on the tiered storage or as the storage on the physical device. That's something to keep in mind. So let's talk about producers, right? So producers are responsible for sending messages to the brokers. Producers have a local message queue, which gives it a max pending message size. So this queue size is a local queue. So basically, let's say you're entering a tunnel with your producer, you have an IoT device, and for whatever reason, it can't connect. So it'll build up these messages until it can finally send. You have the option to block if the queue is full, and you can also do queue management, which means you're working for a broker using a receipt. The other thing too is there's message batching, so you can send, chunks of messages in groups and store it as a single unit. And this is very good for, networking issues and performance. There is also a redelivery concern for unacknowledged messages, so you can do batch index acknowledgements. We'll cover partitions, producers more a little bit later, but that kind of covers the basics of it. So partitions, what are they? Well, basically, you can use them if you want, and I generally say they're necessary. Partitions are how you do parallel processing with systems like Pulsar and Kafka. So basically, they are what allow you to handle, large volume traffic applications. So the more partitions you have, the more parallel processing of the data you have. Partitions are also used for message routing. So basically, you can do partitioning of the messages based by key. So particular keyed messages will go to a partition. You have round robin, and then you also have custom producing messages as well. And then there's hashing schemes. You can dynamically update these partitions in a topic, and these settings are done on the Apache Bookkeeper side. So all topics will be becoming a partition topic, right? And message ordering is guaranteed from the same producer and from the same key in the same partition. So kind of putting the concepts together, right? You have a producer that writes to 3 partitions, and each of them are on 3 brokers. And then you have 2 consumers. One consumer is reading just 1 partition, and another consumer is reading 2 partitions. So this is what I mean by the power of partitions, right? The more partitions you have, the more consumers can read the data. And the more consumers reading your data, the faster your application can be.
We have 2 good questions. Maybe you would
I
like to
expected.
3 questions.
I
Maybe.
expected this. Go ahead.
Yep. So I will start in order of coming. First question, I think you will like, from
Mm-hmm.
Ashish Kumar. Has Pulsar better performance than Kafka?
It depends. It depends. So basically, Kafka stores, you know, the message bus and the messages themselves in the same broker. So there's no like networking there. So when everything's working in Kafka, in theory, that should be faster. However, if you've ever operated a large Kafka cluster before, that's just simply a nightmare because you're going to deal with issues of running out of disk space and you need to add a new broker. When you add a new Kafka broker to a cluster, that has tremendous operational overheads. The second thing, too, is you can't do tiered storage yet. I think that's an upcoming feature. So, in that regard, logically speaking, Kafka should be faster, but it comes at a great operational cost. Now, you do have a much more interesting feature of Apache Pulsar called non-persistent topics. So, non-persistent topics are exactly like Redis topics, meaning these topics will exist only in memory. Now, why would you want something like that? Well, if you want to make a Pulsar topic be as fast as conceivably possible, you could do an in-memory topic only, and there's a lot of advantages to that. One, it's in memory, and it's replicated, multiple times, and it's highly available. So that is very available, and it's exponentially faster than Kafka, but you don't have, your data written to disk. So Pulsar's flexible, and that's kind of the value of it has over the performance of Kafka. Next question.
Yep. Good. So, question from Tanay Balani. If
Mm-hmm.
producer and consumer are in different zones under different bookkeeper with totally
Mm-hmm.
different GDPR, when we will require a novice microservice to share data from one queue or message server to another?
Yeah, so that's called multi-tenancy, and that's when you set the policy at the namespace level. We don't really cover that in today's workshop. In fact, I don't even have slides for it for today, but we can cover that more into the third workshop, which is all about integration and design patterns with Pulsar and, deployment patterns, how to do geo-replication, all that fun stuff. But broadly speaking, what you do is you set a tenant to span multiple geographies, and then you assign specific users to it. Now, in regards to GDPR itself, Pulsar does let you do encrypted messaging. So if you need to encrypt individual messages, there is some Java code on the website on how to do that. You can also delete messages when you need them, and non-persistent topics are a guaranteed way of deleting messages. So there's different ways of doing GDPR. It's a common question I get from banks. So if you're interested in talking more, I can run you through those slides. Send me an email, coordinate through Alex, and we'll get back to you. Next
Yes,
question.
definitely. Question from Saverio Guzzo. Ciao, Saverio. Can you process just the messages what are still within their TTL?
If they're still within their TTL, yes, definitely.
I'm not sure I get the point. Maybe point is in the just. So
So if the messages still exist in the broker, you can read them with either another consumer or
mhm.
reader. You can also move the offset. So just like consumer groups in Kafka have reading positions, Pulsar have subscription group positions called offsets. You can move them to an earlier point in time. So if you need to reread acknowledged messages, you do have that facility.
Yep. Question from Smith Gopalan. In Cassandra, touching multiple partitions at the same time is not recommended. Are partitions in Kafka and Pulsar different from partitions in Cassandra from this point of view?
Well, I'm not a Cassandra guru. I've never actually used Cassandra. I'm more of a Kafka person. But you do have the ability to do like local quorum with Pulsar, so you can acknowledge your messages to just one particular cluster, and then let the data replicate asynchronously in the background. The other option you have is if you're like a bank or a large organization and you can't afford to lose any message, is you can do global acknowledgement of the messages, right? You send your data to one cluster, you wait until it's replicated to the other cluster, and then your consumer can read it after it's been fully acknowledged by the producer. So I hope I answered your question.
I think so. And the last one,
Okay,
I
go.
mean, yeah, we have to move on. You see, like there are a lot of questions, and that's amazing, actually. Thank you for all the questions.
Thank you for your participation. Last
Yeah.
question, though.
We will answer ours in the end if we will have time for questions and answers. And if we don't, then please feel free to contact us on Discord. Ruby. Ruby, I mean, it's the name of the one who asks, not the language in this case. Or maybe that's the language asking questions. So, to recap the difference with Kafka, here each partition are not assigned to the broker, because that's the issue with Kafka, right? When it comes to adding a new broker, we will have to rebalance.
Yeah. So when you add a broker to Kafka, it's a massive pain. Or adding a partition or just doing any kind of operations with Kafka is a pain because fundamentally all the core technologies are, through a single server, which you can then replicate. The power of Pulsar is the fact that each component of the Pulsar service is open source. So Apache Bookkeeper has been around for a while, a broker as well, and Zookeeper. So they're all independent clustering technologies that have all their own different ways of operating, and they're all very easy and focused on what they need to do. So if you need to, for instance, add more processing power, you can add more brokers. If you need to add more storage capability and more processing power for storing those messages, you add more bookkeepers. If you need more metadata, just add a more Zookeeper. But honestly, Zookeeper plays such a small role in Pulsar, you're really fine with just 3 nodes, and that should be good. All right, guys, we really need to
Yeah, we
get
really
on
need to
because
move on. And last point before we move on, I see many dozens of people watching us live right now, but I see only 33 likes set on YouTube. And then, guys, we are answering your questions. That's not fair. Set the thumbs up right now, and we will move on.
Okay.
We are good to go. So, Zik, what's next?
So partition topics are not bound by the number of brokers. They're implemented as internal topics, right? And partitions allow you to do parallelism. They increase control, they do throughput, and they increase the routing mode. So consumers have different ways of doing subscriptions. So consumers use subscriptions to track message consumptions. A subscription cursor is a reference point or an offset to track the current message consumption. So it's used to keep track of many things, right? You want to know your reading position in a book. So if I open a book, like developers are the new kingmakers, you can consider this to be a ledger, right? And I need to know my reading position in it. So a very good example would be your offset. You take your offset, you put it in your ledger, that's your reading position. It's an offset. So I know I'm on page 33. That's why I call it Apache Bookkeeper. You keep track of all your books. So you have queues and different ways of keeping track of these. So consumers subscribe to multiple topics. Generally speaking, they have to be in the same namespace. You can't have a consumer spreading multiple namespaces or tenants. You can have the same user, but the consumer application ideally should just be federated to what it's trying to do. You can subscribe to multiple topics within that tenant or namespace, and you can follow a regular expression if you need to. And subscriptions start from 2 different positions by default, either the earliest or latest. And like I was saying later, consumers can work in a geo-replicated fashion, so they can only read from a replicated subscription state. So you have that ability as well. So generally speaking, consumers attach to a subscription and they consume from a broker, which has a subscription cursor. You can receive messages asynchronously or synchronously, and consumers will request to receive messages via flow control as a receiver queue. And we'll cover acknowledgements in a bit. So consumers are flexible in Pulsar. You can use consumers exactly like you would in Kafka, and you can also use it like an MQ traditional messaging system. So there's really no consumer group. Well, there are if you're using key shared or shared, and you have different methodologies between them. So basically the first two subscription modes are very traditional queuing systems. So we have exclusive, which is a default mode. Exclusive is very good if you want a particular application to always read from a particular topic, and you want no other application to read from that topic. So consumer A is exclusively subscribed to that subscription, and no other application can join. Why would you want an exclusive mode? Well, basically, if you don't want to add any consumers, you don't want to do any parallel processing, you just want that one consumer running. The next other feasible option is called a failover subscription. This is good if you have the computer resources to have a second consumer running in case the first consumer fails. So this allows multiple consumers to attach to the same subscription, only one master consumer, which has the highest priority of messaging, and messages are delivered to the master consumer only. The delivery of messages to the next consumer fails in line when, the consumer fails to acknowledge messages, it times out, etc. Next is shared mode. The shared mode, this is a very Kafka-esque pattern. So basically, depending upon the number of partitions you have, or actually the partitions don't even matter here. You can do shared mode just based on consumers, but partitions are how this works. You need partitions. So basically it allows you to have multiple consumers attached to the same subscription. The messages are distributed round robin. So if there's 3 consumers, each consumer will receive exactly one message, and any message is distributed to only one consumer. When a consumer fails, all are sent to the messages that are not acknowledged and will be rescheduled to the remaining consumers. Now, key shared mode is an interesting feature. But basically what this does is it allows you to do key-based message delivery on a consumer side. So a consumer will subscribe to a topic and a particular key, and that consumer is guaranteed always to get both the data in that topic and only those keyed messages. This is extremely useful if, you're trying to write business logic that depends on a particular key and you're trying to solve a particular problem. So I can't emphasize how valuable this is. Doing key-based messaging and consuming with Kafka is very painful and it's not easy. With Pulsar, it just works. So message consumption has a lot of flexibility. You can do fan out, publish and subscribe. You can have multiple consumers and unique subscription names per consumer. And the default subscription mode is exclusive. Now queuing has multiple consumers. They can share the same subscription name and you can do things. There's also plenty of flexibility. You can combine these two in different ways. You can subscribe to multiple topics. So by default, one consumer subscribes to one topic, and multi-topic subscription is doable. You can give it a list of topic names, or you can use a regular expression pattern. But ultimately, they have to belong to the same namespace. So namespace is a security policy and a way of organizing data. So let's talk about readers. So you can read from the same topic directly with no subscription needed. And you just basically, you can also explicitly specify a message ID. So if you need to read a particular message, you can do it. And you can then iterate from one message after the other. Now, another new feature that just came out is transaction support. So what this does is it allows you to send messages atomically to Pulsar and then read messages atomically to Pulsar as well. Now, these transactions are not enabled on a global cluster level. It's only transactional to a single cluster. Global acknowledgements will come later. Transactions, I mean. But it's on the roadmap. At least I see it on the roadmap. Next, we have message deduplication. So basically, producers, each message is produced to a Pulsar topic, is persisted to disk only once. This is useful if you're dealing with a lot of duplicate messages. So Pulsar has the ability on the producer application side and the broker side to remove extra messages. So another thing you need to know is that consumers by default in Pulsar have dead letter queues. So basically every programming language, whether it's Python, Java, Ruby, C#, all these languages that connect to Pulsar have dead letter queues built into it out of the box. So a dead letter topic enables you to consume new messages with some of the messages which cannot be consumed successfully by a consumer. And in this messages that are failed to be consumed are stored in a separate topic, which is called a dead letter queue. You can then decide how to handle those messages in a dead letter topic. So the code you're seeing is in Java. By default, dead letter topics follow the same naming standards. The other interesting thing about Pulsar is you can do priority-based messaging. So basically, if you set a priority on the consumer level, you should theoretically be able to consume the messages faster than others. Delayed messaging. So delayed message delivery enables you to consume a message later rather than immediately. So in this mechanism, a message is stored in Bookkeeper. There's this delayed message tracker, which gives you to set a time index. So it could be now plus a certain amount of time in memory after it is published to the broker. It is then delivered to the consumer once a specific delayed time has passed. So you can in fact use Pulsar. I'm not going to say as a cron tab, but you could do delayed eventing, which is extremely useful. So basically, a broker saves a message without any check, and when a consumer consumes a message, if the message is set to delay, then the message is added to the delayed delivery tracker, and a subscription checks and gets timed out messages from the delayed delivery tracker. So message delivery only works in a shared subscription mode. In exclusive and failover subscription modes, the delayed message is dispatched immediately. So let's talk about acknowledgements. So basically, a message is persistently stored and deleted only after all subscriptions have acknowledged it. So you can acknowledge your subscription of particular messages either individually, meaning one at a time, or cumulatively after you've read several pages in your book, so to speak. So you can acknowledge a group of messages. You can also have an acknowledgement timeout, so it will automatically redeliver the messages if you timed out to read it. More interestingly enough, you can do what's called a negative acknowledgement. So if for whatever reason you don't like the message you received and you couldn't process it, you can ask Pulsar to send the same message again. Maybe there was some network error. Maybe there was some, nefarious actor injecting bytes into your network. You never know. But you can negatively acknowledge a message to request a new message immediately, so you don't have to wait for a timeout. And that's a feature Kafka doesn't have. You can set your timeout, but you can't explicitly ask for a new message. So this gives you precise control. So again, you have dead letter topics, and then finally you have retry queues. So retry queues are different from a dead letter topic. Basically, a retry letter topic is like, let's say you're running a bakery, right? And you have a lot of customers standing in line, and you're serving a lot of customers cookies, and people are in line. Now, let's just imagine that you have an order ready for one customer, and the customer is not there to receive the cookie. So what you do is you set that message aside to the retry letter topic, and then when the consumer returns, it can then receive the message. So that's kind of what the retry letter topic it is. It's just for retrying messages. A good use of this is if you're calling a third-party API from a consumer application, right? So if you're using a third-party API service, that's where retry letter topics are extremely useful. I can't emphasize how valuable a retry letter topic is if you're using third-party services. Same thing with dead letter topics. If your third-party API is giving you bad data, you need to clean it up somehow. So that's kind of the use of both of them. So summarizing everything. So basically you have your retention policy. So basically once a message is acknowledged by default, it should be deleted eventually. The retention policy lets you store messages even if they have been acknowledged, and the expiry policy sets the TTL for messages that have not been acknowledged. All right, lab time. So now we're going to do that Java code. I'm sorry to keep you waiting. I know everybody's been waiting to do this one, but time to do that Java code. Should I stop sharing my screen, or should everyone just do it? Or
I think you keep sharing.
okay,
There is nothing to switch to. I can do those steps maybe if you want me to demonstrate the lab, but I better ask our guys to do that on their own.
Okay.
If you have laptop or computer, you have to do it right now. We will give you some time. Or if you are on a mobile phone, not at home, not in the office, and cannot do it right now, then go get some tea or lemonade or whatever you prefer, and do this exercise again later. Again, if you're doing this exercise with us together during on Monday, 14th of June, you have to follow this link on the screen. If you are doing this exercise after that, so if you are watching the recording, then maybe, you know what, I will indeed switch to my screen and show what to do in this case. I sent the link already into the YouTube chat, but I want to show it again, so I will indeed switch to my display. And if you are doing exercise, don't get distracted. Keep doing things. That's for those who are watching the recording. So it's going to be katacoda.com/datastacks, and here somewhere down you will have this Pulsar series. Where is it, by the way? Apache Pulsar learning series. Here we go. A hands-on introduction to Apache Pulsar. You push start the course button and then select the appropriate scenario. We have 5 of them. Now we are doing creating Apache Pulsar producers, consumers, and readers in Java. And the last one for today will be the third one with SQL over Pulsar. Yes. Next. So I think I can switch back to your display.
Okay, I'll share my screen again. Should I go through the lab with everybody? Would that be beneficial, or what do you think?
You see, that's always a good question. I see people when we are doing exercises when they don't do it manually and just watch what we are doing, and I don't like that.
I want them to learn, yeah.
Yeah.
So
maybe we can answer. And the number of people doing the second one, it grows a lot.
Beautiful.
Yeah.
Beautiful.
Cool. Maybe we can answer questions meanwhile.
Yeah, let's answer questions, and then we'll get into SQL after this.
Yeah, cool. So there were some questions to talk about. Give me a second. Okay, maybe this one for the beginning. Bala Narasimha Rao Anne asks, is there a replication factor concept or something like that? Like, how is the high availability is ensured?
Yeah, that was covered in my first workshop, but basically, there is what's called a quorum read acknowledgement and a quorum write acknowledgement and ensemble. Ensemble size determines the number of machines in the cluster. Acknowledgement write determines how many machines should be written to, so that's kind of a replication factor. And then acknowledgement read is how many to read from. I think that's a global setting. You might be able to also configure something on a topic level, but at least as far as I know, it's a global setting. But you can read up more on that in your own time.
Okay. So, not a question, but I just want to voice it up. Smita thinks it's an awesome lab.
Thank you.
Yeah, indeed. So, what's next? Question was answered in the chat already, so we can skip that if you want. Question is, what's the difference between a reader and a consumer?
So a consumer has a let's look at this Kingmaker book, right? So a consumer, it reads the book. And it tells Apache Pulsar my offset, my index, my reading position. Now a reader could be someone on the subway, right? That just reads the book, but it doesn't keep its reading position anywhere. There's no offset. There's nothing. So reader is just a way to take a peek inside the data. That's what it means.
Mm-hmm. Okay,
I
yeah,
hope that.
that's. Am I right? What in most, I don't. My working experience was mostly with RabbitMQ.
Yeah.
Am I right? What readers are rarely use it. Well, in comparison with consumers. So consumers is the main tool to work with data.
Yeah, I don't really think readers are used all that often. They're useful for like taking a peek inside your data.
Mm-hmm.
It's also a good way of just like it's good for like auditing, you want to just like see like what's message. Like basically if someone tells you there's a problem, they say, okay, let's look at page like 23. That's what it is. So a reader is just basically a way to take a glance at a particular message in a particular offset. So that's what it's used for, as far as I know. But I could be wrong. I mean, Pulsar is a flexible platform, and we'll never know what people are going to do with it. We're just making this new technology.
Mm-hmm. Great. And I think the last one for now, because we have to move on.
Mm-hmm.
I'm not sure I got it. How does a consumer consuming from a specific partition work in conjunction with a KD type?
KD type? What is KD?
Yeah, that's my point as well. So K, single quote D. Ruby, if you would clarify what you meant, we will be happy to answer. And by the way, I wanted to say I see so many people moving on doing their work in Katakoda dashboard, and I also
Beautiful.
see so many new likes. So thank you for liking this video. It looks like you are happy to be here with us as well. Good. And last question, which I will answer very briefly. Smitha asks, at the end of a session 3, will there be a slide going over the differences between Kafka and Pulsar? It would be helpful. My answer is, take a look. We have something much better than just a slide in the end. We have a real webinar for like 1 hour, 1 hour approximately, yes?
Yep.
Taking care of all the main differences between Kafka and Pulsar. And it's recorded and it's available already for you for free. So I will get the link. I will set the link to the YouTube chat, and I will attach the link to the additional resources to our GitHub repo. So you will have access to this link. While Zeke will be talking, I will take care of that.
Thank you. Any other questions?
Nothing what we would answer by voice. I would suggest us to move on.
Okay. Are we ready to move to the rest of the workshop?
And let me check. So how it goes on Katakoda, everyone. I see 26 people started the work, 29 already, but I see only 4 completed it. So it looks like Java client takes longer time. And
there's a lot more stuff.
Yeah, there are a lot of more stuff indeed.
More clicking, yeah. It's a hard one. I would love to just do it for you, but that you won't learn anything, will you?
Yep. Regarding the further questions, if you have further questions to us, easiest way to communicate with us is via our Discord server. I will send the link to the YouTube chat right now. Boom. Done. So, if you are done with the second lab, please set the thumbs up in the YouTube chat so we will know you are ready. Or maybe not the thumbs up, but okay. Or maybe happy smile. Whatever you prefer. But I want to see this number growing. Okay, it's already 8. So people start to finish.
That's good.
Yeah, start to finish sounds a little bit funny, but that's um,
When we get
that's
50%, I'll move on.
yeah. So please move on, do your work on the Java client, and we will move on. Notice what you don't need to have like particular knowledge of Java. I believe there are some developers with non-Java experience, and that's completely fine because basically all code is prepared, and you just need to follow that and try to get as much from it as possible. It will be easier if you have background with Java, but anyway, as long as you can read in English, it's it will be very easy. Like, you know what, Zik? It was really
Mhm.
easy for me to learn English. It looks very similar to C++.
It does. It is very similar to C++.
Good. So I will meanwhile check for some questions. Oh, okay. Good question from Smitha again. Is there a certification for Pulsar?
We're hoping to.
So yeah, answer is, at least from my side, from what I've heard, at this moment, there is no certification, at least not from DataStack's side. I'm not responsible for our companies, obviously, but I believe we need to have it.
Yeah, we
And
do. We do.
personally, I will try to push this idea to add courses about Pulsar into the academy.datastacks.com, and obviously add certification for Pulsar too. But it's definitely will take time, because you know what? Certification must be valuable. Certification must really validate your skills, and that means what it will take some significant time. So I won't expect any Pulsar certifications from DataStax in at least within next 3 to 4 months, I would say. Sorry, we want it to be really high quality, so we will not hurry doing that.
Okay. Yeah, we'll just take these content and add some more. I think we need harder questions, really. Harder questions, harder labs. That would probably get us to good certification standards.
Yep, yep. Okay, so I see more people are setting thumbs up in the YouTube chat, and
Beautiful.
Katakode dashboard gives me 32 started, 10 completed, which makes 1/3. So, okay, we are almost on the end of a workshop.
That's what I'm worried about. Should we just move on because we have a third lab we have to do?
Yeah, we have a third lab we have to do today. We have to move on, and we have quiz, by the way, to play a game and to dispatch prizes, those who did the best. So, you know what, everyone, I'm sorry, we have to move on. And if you haven't done with this workshop, you can do it after the workshop. This training infrastructure will be terminated after some time. It will be terminated in half an hour, but you still will be able to do the exercises on Katakoda as I shown to you using different link. So I think at this start, I'm sorry, we have to move on.
All right. Let's talk about schema management. So basically, if you're coming from a Kafka world, you're probably very familiar with the concept of Avro. But essentially, a schema registry is a way of giving your data data governance, essentially. So what this means is you apply a rule set to your data. And schema is also useful for SQL. We'll cover that later. But basically, your data has type safety, which is very important for protecting your consumers from reading malformed data with bad fields. And the schema registry itself is operating on Bookkeeper, so it's not a separate service you have to run. You can also register schemas via a client application or a REST API, and you can do JSON Avro, and I think even protobuf, if I'm not mistaken. But generally speaking, the industry standard is Avro. Pulsar stores the current schema and ensures that the producers and consumers conform. the schema will be validated, and there is schema evolution, just like an Avro schema. So your existing Kafka Avro schemas should go right into Pulsar very nicely. Now, I have a Python example. This is code for the upcoming workshop. So, next week we'll run another workshop in COVID-19 data, but I wanted to draw attention to the schema here, right? So basically you create a new class where you give it all of its attributes, a date, which is a string, and then some integers, and then a country. So you can see the field type here right in front of you. And when you actually call it, you connect to your Pulsar cluster, you create your producer, which then you define the schema to the type, and then you actually send up to Pulsar using the producer.send method, and you have to compile, a record. So as you can see in the very middle of the screen, we have record is equal to COVID-19, and then you have all the fields. So that's kind of the power of schemas, and it's very, very easy. And I happen to love Python. It's such a readable language. So the producer side of the schema, basically the producer sends the schema information to a broker. The broker then checks to see if the schema is registered. If it is, then it returns the schema version and the producer is connected and done with its job. If it's not, then you have to check if, the producer has the ability to even write schemas. And if it is, well, then it writes the schema manager. Now, how does the consumer do this? Well, basically, as you know, a consumer subscribes to a topic, but it first checks to see if there's a schema for this message it's receiving. If there is, then it checks for the compatible strategy, and it will get the data. If it's not, then it will see if the schema is registered, and then it will upload it. I can take schema-related questions afterwards because we really have to do the next lab. We have a limited time. SQL on Pulsar. So basically, Pulsar messages have a well-defined schema, right? Pulsar is a built-in schema registry. Therefore, you set schemas on a per-topic basis, and this feature is only available in Java, Python, Go, and C and C++ clients. Now, Pulsar SQL is actually not a Pulsar product at all. It's actually made by a fantastic other Apache project called Presto. So Presto is an open source distributed SQL engine for various different technologies, and it has both a coordinator and workers. So Presto wrote a Pulsar connector, which allows you to read data on a Pulsar cluster via PrestoDB, which is an open source project. So you have many different commands. So basically, the example you're seeing here is a data schema. So at the top, you have a job search request schema, which has, trace ID, a user ID, request ID, city ID, and keywords. And then you have another schema called job search response. So let's say we wanted to display the top 10 keywords in today's job search requests. So basically, you would do a select star SD keywords from Pulsar, looking through the topic search job. Basically, we're the current date, as you can see in the above. You can route by the keywords. Another query you could easily run is selecting the trace ID. So you do trace ID from the response attribute. So the overall Presto architecture. So Apache Pulsar is used to store streams of event data, and the event data is structured with predefined fields, right? Because we're using schemas. Now, with the implementation of schema registry, you can then store structured data in Pulsar and query the data using PrestoDB. As a core feature of Pulsar SQL, the Presto SQL connector enables Presto workers within a Presto cluster to query data from Pulsar. The query performance is highly efficient and scalable because Pulsar adopts the two-level segment-based architecture, as you can see in these diagrams. So topics in Pulsar are stored as segments in Apache Bookkeeper, and each topic segment is replicated to some Bookkeeper nodes. This enables concurrent reads and writes through throughput, and you can configure the number of Presto workers. The default is up to 3. Finally, the wonderful thing is you can deploy a Pulsar SQL worker cluster as well on multiple nodes. So as you can see from this select star statement, you can see all the different SQL worker nodes running. So understanding the Presto terminal, well, we can skip this slide, but essentially Presto Pulsar SQL is a distributed worker technology, and it's very good in that you can query live data, provided your data follows a schema. If you don't follow a schema, you can't do any SQL. Sorry, guys, but if you want to use SQL on your data, you need to use a schema. Rule number 1. All right, final lab. Final lab. Let's do it. By the way, you can keep the other lab running if you're still doing it. Just open another terminal is what I would advise.
Yep. There is a little limitation we found out, but basically every lab is executed in the same
VM?
In the same VM, yeah, in the same container. So they now intersect somehow, usually on Katacoda, every scenario executed in the new container. So if you shouldn't have any problems, mostly. If you have some, write about that in the YouTube chat, and Stefano will help you with that because he ran into this problem already. So he knows how to solve it.
I think next time I'll give 2 links, one for the live audience and one for the YouTube audience. That would probably be very helpful. Or we could update these links later, to point to the normal Katacoda link. That might be a good idea.
Yep. So while you are doing the exercises, I see what we have. How many people? 24 people started the last lab. Only
Yay.
3 finish it.
They finished it. Okay.
3 finish it, yeah, already. Well, they did
How?
that like 1 hour ago.
That's I told them don't do it.
Yeah. But okay. So I want to check while you are doing the lab how it goes with the question. So give me a moment. Gilan Shaikh, I'm getting exceptions while executing the commands. It will be really hard to support you in the YouTube chat, so I suggest you to join our Discord and publish the screenshots so we will see what's going on with your infrastructure and with your environment. Ritvik Srivastava. So basically the same story. Can't run show catalogs in Pulsar SQL client. Showing error. We need to know which error. Then Jai Gaurav. What is an event hub?
What is an event hub?
Yeah, what is an event hub?
Okay, well.
Do you have an idea in this context?
Yeah. Yeah, I'm just going back to your slides.
Okay.
Okay. So an event hub is just like in this diagram, right? It's an event manager. So essentially, service provider A sends data, and then service consumer reads the data from the event hub. So an event hub is, it could be a topic, it could be multiple topics, but it's basically what Pulsar or Kafka or RabbitMQ, what all these technologies are trying to do. It's a messaging-oriented middleware. Did I answer your question?
I think so. It wasn't my question, you see, so I cannot confirm that.
Yeah.
There is a question I really like. I believe this question shows we did our job well.
Okay.
So question is from Vemal KS. Kindly suggest any ebook for Apache Pulsar to learn more.
So there's a very great author here. His name is David K. And it's a Manning book he's publishing right now. It's called Apache Pulsar in Action. So we need to provide a link to that book in the chat window, don't we? I apologize, I can't pronounce your full name. Let's see. Apache Pulsar in Action, David K. Yeah, David Kujurmagad.
Yeah, I see it's by Yeah, David Kierumgaard. That's by Manning Publications,
Mm-hmm.
Publisher's House, and I can send a link on that. So give me a moment. Yeah, that's it. YouTube chat. Here we go. Vimal. So give me a moment. Mal. Boom, boom, boom. Good. And Ritwik posted the screenshot of error in Discord. Okay, we will take care of it. But right now, we have to finish in 2 minutes and we still have things to do. And thank you, Stefano, for helping and assisting all the possible issues in the YouTube chat. Good. Pokemon Bonnie, you know. So, what's the next step for us? Tell me, please. We are done and we are proceeding to quiz.
Yeah, you want to proceed to quiz, or you want to do
No.
the
I
SQL
wanted
lab?
to ask if you have any slides left. That's my question.
Ah, I have no more slides. It's quiz time.
So okay, it's a quiz time. Perfect.
I'll stop sharing my screen.
Okay, give me a moment then. Yes, you can switch off. And so, ladies and gentlemen, I see not all of you have completed the third lab, and some haven't completed the second. After the workshop, you will have time to do it on your own pace. Via our link, instances will stay for some more minutes, and then they are terminated. You can do the same exercise as I've shown to you at katakoda.com/datastacks Pulsar learning series. Those are the same exercises. You can proceed. Don't forget to make the screenshots of successfully completed tasks. You will need them submitting homework for the participation certificates and badges and so on. And now we are switching to quiz. So get your mobile phones, switch to Menti, and we are going to ask you questions and you are going to answer fast. If you are doing it fast enough, you will win prizes from the data stacks. And code is the same, 26484290. And I want to see everyone joining. I want to see literally everyone here. Okay, that's it. How many people do we have? 30. I see we have over 70 people on YouTube and only 30 people on Menti. And you know what? Don't make this win easy for those who will get the prizes. Make the competition. Menti.com is completely anonymous. You don't have to put your mobile phone number or email or I don't know, credit card. Just jump in, answer the questions on your mobile phone and win the prizes. So I will give you 15 more seconds to proceed. Jump in again, menti.com, code 26484290. I will show you the code once again, 26484290. I hope you can see that right now. Okay. So, how many people do we have right now? Over 180 concurrent viewers. And I have only 35 people on quiz. So, okay. If you already got your prize and don't want to prevent others from getting theirs, that's quite fair. We will start then. So, ladies and gentlemen, I gave you enough time to jump in. That means we are starting right now. We will go. So, answer fast to get more points. That's the question number 1. What does producer do? It sends data to the consumer. It sends data to Pulsar. It reads data from Pulsar. It reads data from the consumer. And I bet many people made a mistake and got into my trap today. Okay, 6. Well, you did well, surprisingly well. I thought you will be in a hurry, in a rush, and you will make a mistake. But most of you answered it correctly. It sends data to Pulsar. Notice, not to the consumer, not like the normal messaging works when you have to reach directly the one who is going to receive your message, but it sends data to Pulsar. That's what right, and you did well and you paid attention. Now I see. It doesn't send data to consumer, and it definitely does not read data from Pulsar or from the consumer neither. So, most of you gave the right answer, but who was fast enough? I see Fire Dancer did great, and Bala Narasimha on the second place, and Artyom on the third one, which is a great result. I see some familiar names here already. Hi Ruby, hi Praful. And that brings us to the second question, question number 2. So, answer fast to get more points. The Pulsar messages are stored on Zookeeper, Broker, Bookie, transit only, never stored. Will it be easy for you or not? How many of you will make the mistake? I'm very curious, and the right answer is Pulsar messages are stored not on Zookeeper, not on Broker, and yes, they are stored, and they are stored on Bookie, which is a part of a Bookkeeper Apache system, which is a part of a Pulsar.
I should have reviewed the architecture a little better in the beginning, but it's okay. Just review the first workshop.
Yeah,
For those.
that's the second episode, so those who join late, they don't know the beginning for foundation. Quite clear. So, Ruby was the fastest, giving the right answer, which brings him to the third place, and that's very well, because first 3 places will get the results. But Fire Dancer and Bala Narasimha keeping the first 2 places. And well, I see what Fitra Alim is like with just few points behind Ruby, ready to fight for the third place. And Artyom has lost his place, but maybe he will recover. Let's see. So, ladies and gentlemen, that's question number 3, and you have to answer fast to get more points. In shared subscription mode, all consumers get all messages. Each message goes to exactly one consumer. You cannot share a subscription. Every message is sent to AWS because sharing is caring. Time is over, and the right answer is in shared subscription mode. All consumers get all the messages. Because shared subscription is used to distribute the messages over multiple subscribers or consumers in this case. So no, share. That's what was the name of the mode when the message goes?
It's round robin is what a shared subscription is. So basically, if you have 3 consumers and there's 3 messages, each consumer will get a message.
Good. So.
No results in that question. Sorry if...
Oh. That is a mistake, what brings Bala directly to the 10th place, away from top 3. But that was quite lucky for Artyom, who makes it back to the top 3. And Ruby was fastest again with a very good result, getting already to the 2nd place using the mistake of Bala. Okay, now Praful Koteka is on the 4th place, following Artyom so close. So, that's going to be question 4, and you have to answer fast to get more points. Which subscriptions are available in Pulsar? Share it, exclusive, failover, $9.99 per month. Some people must be worried at this point. And time is up, and first 3 answers were correct, so whatever you choose, share it, exclusive or failover, you was right. And regarding the money, Apache Pulsar is an open source system, so you don't pay for it. only for the infrastructure you use to run it. Okay. So, chat is quiet, no questions in the YouTube chat. Everyone is very focused, and that makes sense. So, who made a mistake and who was fast enough to get higher? Are there any changes? Okay, there were slowdowns. And Fitra Alim was the fastest one, jumping directly to the top 3 on the leaderboard, with Fire Dancer and Ruby holding first 2 places and Manjit on the 4th. Okay, that's a competition. That's what I like. And that's question number 5. So answer fast to get more points. What is the name of connectors to push messages from Pulsar to other systems? Think, source, sync, sync, seek. Some of you may know the answer, but who will be the fastest? And yes, definitely, sync. Sync is the name of the connector to push messages from Pulsar to our system. That brings us to the next question I will ask in a moment. And I can't believe on the leaderboard, 2 leaders made a mistake jumping back. And now we have only 5 people who made no mistake before. Fire Dancer, Petra Alim with the fastest answer got to the 2nd place. Bapi was on the 3rd. Welcome to the top 3, Bapi. I hope it feels great. And Artyom is on the 4th. Well, that looks interesting. So, you know what? I will not make you wait. Wait, that's a question number 6. Answer fast to get more points. What is the name of connectors to pull messages from other systems? Think, source, sync, sync, seek. That is interesting. Just 1 word difference, but correct answer is not the same. No, yes, that was easier for you. Like, why the second question is so much easier? Yes, it's source. Source is indeed the connector to pull messages from other systems. So, what about leaderboard? And Petra Ali makes a mistake, I can't believe. Okay, that is like really interesting one. Ruby was the fastest, getting back to the 5th place, but will it be enough to compete again for top 3? I don't know. So, that's going on here. Fire Dancer on the first one. Bapi made no mistake as Fire Dancer and stays in a approximately 100 or even like 200 points difference. Quite solid difference already. Praful Kotaka made no mistake and keeps the 3rd one. Artyom hounds him just shoulder to shoulder, step to step. That's going to be the last question, ladies and gentlemen. So that's question number 7. Last question. Release, warm up your fingers, release your mind, get ready. We are going into the last competition. Answer fast to get more points. When a message is deleted from Pulsar, when they are acknowledged by the consumer, then TTL is configured and the time has lapsed. When you send a delete message command from the consumer, immediately delete it when requested. Time is up. And most of you made no mistake. Both 2 answers were correct. Or then they are acknowledged by the consumer on that TTL is configured and TTL is elapsed, then they will be deleted from Pulsar. And last 2 answer options were wrong. So looks like most of you made the right answer, but who did it fast enough? Who was fast enough and who made no mistake? Saverio was the fastest one, getting into top 10, but that was not enough to make it to top 3. So I congratulate Fire Dancer with the 1st place, 6,058 points. That's a good result. Bapi on the second with a very low difference over 7 questions with 5,990 questions points. Artyom, congrats with the third place. And then if you are in the list, Fire Dancer, Bapi, Artyom, please make a screenshot of your winning screen. I know you have winning screen right now. And send the screenshot to check.fryer@datastocks.com. Well done. And yeah, Praful Koteka has 6 points difference to a third place. Like, take a look at that. That was so close, really, like 6 points difference. Artyom, you have some luck. That's indeed very good result. If you didn't make it to a top 3, don't worry. It's still quite a cool thing to be on our leaderboard because many people competed and you did well. And if you are not in the leaderboard, don't worry and don't take it too personal. What really matters is like knowledge and skills, because your knowledge and your skills bring you better salary, better job position, more interesting tasks to do, and that's just cool in the end. So congrats, and a couple of last slides. First one. Please give us feedback. I won't stay for this slide for a long time, but what did you like the most in the workshop? What would you improve? Which topics we have to take care more in the last episode, which comes next Monday? Or maybe you want us to run next Monday learning on some particular topic, because this series will be over. Thank you so much. I will keep this window open and you can write your answers even after the workshop. That brings us to the last slides. So, next week, last episode, and that already feels a little bit sad and disappointing because it was so fun working with you. And next Monday will be the last episode. Maybe we will have to organize something like bonus episode. What do you think, Zik?
Bonus episode is always a good idea. I think we should do it.
Yeah, because like I don't want to stop this show speaking about messaging, queues, notifications, Pulsar. It's all cool. So, what to do and how to get to the third episode? Go and subscribe now. datastocks.io, dtsx.io/ess-ep3. Link is on the screen. And that's going to be very interesting. Can you give us a little teaser? What are we going to do next week?
Yeah, so we're going to be doing some sync and source stuff, you know, writing into Cassandra, writing into Elasticsearch, maybe a Pulsar function, we'll see. But it's going to be a lot of, you know, how to use Pulsar in an enterprise environment. And we'll cover, you know, multi-tenants and georeplication a little more in depth as well.
Yep. And one of our attendees just found a mistake on this slide. Yes, it's not going to be 14th, but 14th plus 7. So 1 week later.
21.
14th is today.
21.
Yeah, 21. Definitely. So, but same time, same speakers. When this week, if you are hungry for more knowledge and skills, if you enjoy our workshops, then subscribe now for the introduction to NoSQL database led by Cedric, Devin, Ryan and me. It's going to be on Wednesday and Thursday. Notice what this link will offer you to choose between Wednesday show and Thursday. There is no content difference, same content, but different speakers and different time zone. So just pick one which works better for you. I see Jai Gurav asks, can we get the recording? Yes, same link. For all the workshops we do, they stay available for you after the live workshop using the same link. Then, one of the most powerful NoSQL databases is definitely Apache Cassandra. I was running Cassandra days for multiple countries, and now we are coming to India. This year event will be online. That's kinda great because everyone can attend that, even if they not live in Mumbai, for example, but in Canada. But still, it's focused on India business and Indian speakers because, well, there are a lot of great people with extreme skills on the NoSQL databases. So, July the 10th, mark the date, Cassandra Day India. This conference is the free, and you can, so it's open, you can register, and you don't have to, the main thing for us, you don't have to be an expert in Cassandra to participate, because we offer you 2 tracks. One track is for NoSQL beginners, and there will be workshops like the one today about what is it and how it works. And second one is for talks, and that's for more advanced audience. Talks already confirmed a speaker from Netflix, principal database cloud database architect from Netflix, Vinay Kumar Chella, and we now are discussing like what exactly he will be talking about, and we will have more great speakers from different industries talking about how they use Cassandra, what are the main features, and so on and so forth. People are asking for the link, and link is to be published in a couple of hours actually. So you will get link on the next episode or on Wednesday on the workshop. But what matters, call for papers is open. So if you are a good expert in Apache Cassandra or related technologies and you have something to talk about, then please, I ask you in person, go to datsx.io/cdindia-cfp and submit your proposal, and we will take care of it and we will get back to you very soon. That was it for today. There is one more question I want to answer. When are Swags dispatched to the leaderboard toppers? As I mentioned last week, we got some problems with our logistics company. We are changing, and that takes some time. So you may get a little delay on getting your swag, but you will get it. I keep it under control, and we will get the points. So, do you have anything to add? Zik, do you have anything to add?
I can't think of anything new to add. If you haven't had a chance to watch the first part of this training workshop, please watch it on YouTube. It is available there. So I really cover like the architecture of Pulsar, you know, the background and history of application messaging, which was led by Alex. And next week we'll cover like, you know, using Pulsar in the enterprise and enterprise messaging patterns.
Yes. Okay, so I believe we are done for today. I will play a little bit of music for you to enjoy, to celebrate your win maybe, and we will see how it goes, and we will meet again maybe this Wednesday for NoSQL databases, and definitely next week on Monday at DataStax Monday Learning event streaming series with Zeke and Alex. Thank you so much for coming, and have a great week. That's why we do it on Monday, to help you get better week.